it's me, Teacher Jeanne. In this lesson, you will learn about factoring difference of two squares, or DOTS. Here are the things you must know, master, and need to memorize. We have the list or table of perfect squares. Given 1 squared equals 1 times 1, we have 1. 2 squared equals 2 times 2, we have 4. 3 squared equals 3 times 3, we have 9. 4 squared equals 4 times 4, we have 16. 5 squared equals 5 times 5, we have 25. 6 squared equals 6 times 6, we have 36. 7 squared equals 7 times 7, we have 49. 8 squared equals 8 times 8, we have 64. 9 squared equals 9 times 9, we have 81. 10 squared equals 10 times 10, we have 100. 11 squared equals 11 times 11, we have 121. 12 squared equals 12 times 12, we have 144. 13 squared equals 13 times 13, we have 169. 14 squared equals 14 times 14, we have 196. 15 squared equals 15 times 15, we have 225. 16 squared equals 16 times 16, we have 256. 17 squared equals 17 times 17, we have 289. 18 squared equals 18 times 18, 324. 19 squared equals 19 times 19, we have 361. 20 squared equals 20 times 20, we have 400. 1, 2, 3, 4, 5, so on and so forth are the counting numbers that we squared. Means we multiply 2 times or twice by itself. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, so on and so forth are what we call perfect squares. Next, we have the table of square roots. Given square root of 1 equals 1, square root of 4 equals 2, square root of 9 equals 3, square root of 16 equals 4, square root of 25 equals 5, square root of 36 equals 6, square root of 49 equals 7, square root of 64 equals 8, square root of 81 equals 9, square root of 100 equals 10, square root of 121 equals 11, square root of 144 equals 12, square root of 169 equals 13, square root of 196 equals 14, square root of 225 equals 15, square root of 256 equals 16, square root of 289 equals 17, square root of 324 equals 18, square root of 361 equals 19, and square root of 400 equals 20. So as you noticed, if we get the square root of a perfect squares, those are equal to its corresponding counting numbers. We're done with the coefficients or constants. Now let's have the list of perfect squares given the variables. First, we have x times x equals x squared. X squared times x squared equals x to the fourth. X cubed times x cubed equals x to the sixth. X to the fourth times x to the fourth equals x to the eighth. X to the fifth times x to the fifth equals x to the 10th. Next, we have the table of square roots given. Square root of x squared equals x. Square root of x to the fourth equals x squared. Square root of x to the sixth equals x cubed. Square root of x to the eighth equals x to the fourth. Square root of x to the 10th equals x to the fifth. So what did you observe? Now, for you to understand, let's have the given a squared. 2 is the exponent. So here we can say that if the exponents are 2, 4, 6, 8, 10, or multiples of 2, or even numbers, they are considered perfect squares. In the given square root of a squared, from the word square root, square means the index is 2, and it is already understood and no need to write it. A is the radicand, and we have the radical sign for the square root. So square root of a squared is equal to a to the 2 divided by 2. So we have the exponent 2 divided by the index 2, and that is equal to a to the first, or simply a. So therefore, square root of a squared is equal to a. Next, we have the square root of m to the sixth. So here we have the variable m. Then we're going to have the exponent 6 divided by the index 2. So we get m cubed. So therefore, square root of m to the 6th is equal to m cubed. Now we need to recall the special product given the quantity of x plus y times the quantity of x minus y, or also known as the product of sum and difference of two terms. And that is equal to square the first term, so we have x squared, minus square the second term, we have y squared, or also known as the difference of two squares, or DOTS. What's new? So here we are going to have factoring difference of two squares. So we all know that factoring is the reverse of multiplication. So given x squared minus y squared, also known as the difference of two squares. So from the word difference, we have the operation minus. So two squares, the first term is perfect square and the second term is a perfect square. And that is equal to, we have the quantity of x plus y times the quantity of x minus y, or also known as the product of sum and difference of two terms. So that is our factored form. The operation of the first binomial is plus, the operation of the second binomial is minus. So a polynomial is a difference of two squares if it satisfies these two conditions. First, it is a binomial and each term is a square. Next, there is a minus sign between the two terms. Moving on to our first activity, which of the following is the difference of two squares? Let's have the first example. Let's check if 9x squared minus 64 satisfies our two conditions. First, it is a binomial and each term is a square. So as you can see, we have two terms. The first term is 9x squared and the second is 64. 9x squared is a perfect square, 64 is also a perfect square, so that is yes. Next, we have the second. There is a minus sign between the two terms. So as you can see, we have the operation minus. So that is also yes. Now we can proceed on getting the factors. And the factors must be written as the product of sum and difference of two terms. So here we're going to use two pairs of parentheses. That indicates as product. And the operation of each binomial must be plus for sum and minus for difference. Or we have plus minus. Now for the solution, let's get the square root of the first term. So square root of 9x squared, we get 3x. Square root of 9 is 3. Square root of x squared is x. So that will be the first term of our binomial factors. Next, get the square root of the second term, 64. We get 8. And that will be the second term of the binomial factors. So 9x squared minus 64 is equal to the quantity of 3x plus 8 times the quantity of 3x minus 8. Now to check if your factor is correct, we can get the product of sum and difference of two terms. So here we're going to square the first term. We have quantity 3x squared minus, because positive times negative is negative. Then square the second term, we have 8 squared. So simplify, 3x times 3x, we have 9x squared minus 8 times 8 is 64. So you got it correct. And that is considered the difference of two squares, or DOTS. Now the other method is using FOIL. So we have the quantity of 3x plus 8 times the quantity of 3x minus 8. So first, multiply the first terms. We have 3x times the quantity of 3x. Multiply the outer terms. We have 3x times negative 8. Multiply the inner terms. We have 3x times 8. Then multiply the last terms. We have 8 times negative 8. So let's get the product. 3x times 3x equals 9x squared. 3x times negative 8, we have negative 24x. 3x times 8, we have positive 24x. 8 times negative 8 is negative 64. Now combine similar terms. We have 24x minus 24x equals 0. So the remaining is 9x squared minus 64. So we got it correct. Next example is negative 4 plus 36x squared. Negative 4 plus 36x can be rearranged so that 36x squared turn into first term and that negative 4 turn into second term. Now let's see if it satisfies our two conditions. First, it is a binomial and each term is a square. So 36x squared is a perfect square and 4 is also a perfect square. So that is yes. Next, there is a minus sign between the two terms. So as you can see, we have the operation minus, and that is yes. So now we can proceed on getting the factors, and that is written as the product of sum and difference of two terms. So we have the two parentheses, so the operation will be plus minus. So for the solution, get the square root of the first term, 36x squared, and that is 6x, and considered as the first term of our binomial factors. Next, get the square root of the second term. So we have square root of 4, and that is 2, considered as the second term of our binomial factors. So therefore, 36x squared minus 4 is equal to the quantity of 6x plus 2 times the quantity of 6x minus 2. Now to check if your factor is correct, we can get the product of sum and difference of two terms. So we're going to get the squared of the first term, so we have the quantity of 6x squared. Minus square the second term, we have 2 squared. So simplify, 6x times 6x, we have 36x squared, minus 2 times 2, we have 4. So you got it correct, and that is in the form of difference of two squares or DOTS. The other method is using FOIL. We have the quantity of 6x plus 2 times the quantity of 6x minus 2. So multiply the first terms, we have 6x times the quantity of 6x. Then multiply the outer terms, we have 6x times the quantity of negative 2. Then multiply the inner terms, we have 6x times positive 2. Then multiply the last terms, we have 2 times negative 2. Now let's simplify. 6x times 6x equals 36x squared. 6x times negative 2, we have negative 12x. 6x times positive 2, we have positive 12x. 2 times negative 2, we have negative 4. Then combine similar terms, we have 12x minus 12x equals to 0. So we have the remaining 36x squared minus 4. So we have the same answer, and that is also correct. Next, we have the third example, 8x squared minus 1. Let's see if 8x squared minus 1 satisfies our conditions. First, it is a binomial and each term is a square. So it is a binomial, it consists of two terms. So that is yes. Each term is a square, that is no. Why? As you can see, 8 is not a perfect square. Next, there is a minus sign between the two terms. So there is the operation minus. So that is also yes. Now, if the given doesn't satisfy one of our condition, that is considered not a difference of two squares. And for the last example, we have x cubed plus 9. Now let's see if x cubed plus 9 satisfies our conditions. First, it is a binomial and each term is a square. So it is a binomial, consists of two terms. So it's yes. Each term is a square. So that is no. X cubed, so the exponent is 3, and that is an odd number and not a multiple of 2. So it's not a perfect square. Next, there is a minus sign between the two terms. So as you can see, that is not a minus. So it does not satisfy our condition. Therefore, it's not a difference of two squares, and we cannot factor it. Let's do more. Factor each completely. First, we have 16a to the 4th minus 49b to the 6th c to the 8th. Now we're going to write the factors as the product of sum and difference of two terms. So we have plus and minus. So to get the first term of the binomial factors, we're going to get the square root of 16a to the 4th, and that is 4a squared. Now to get the second term of the binomial factors, we're going to get the square root of 49b to the 6th c to the 8th, and that is 7b cubed c to the 4th. So we have the quantity of 4a squared plus 7b cubed c to the 4th times the quantity of 4a squared minus 7b cubed c to the 4th. Next, we have the second one, m to the 12 minus 4 over 9 n squared. So again, write it as a product of sum and difference of two terms. So first, get the square root of m to the 12, we have m to the 6th. Now, if the given is a fraction, we're going to get the square root of both numerator and the denominator. So, square root of 4 is 2, square root of 9 is 3, and square root of n squared is n. So, the factor is the quantity of m to the 6th plus 2 over 3n times the quantity of m to the 6th minus 2 over 3n. Next, we have the third one, 8x to the 11th minus 50x. So, as you can see, 8x to the 11th and negative 50x are not perfect squares. But here, we can factor out the common monomial factor. For the numerical 8 and 50, we have the GCF or greatest common factor, which is 2. And for the variable x, we have the least exponent. We have 1, so we have x to the first power. Next, we're going to have 2x as the common monomial factor. Then write the remaining as the product of sum and difference of two terms. So square root of 4x to the 10th is 2x to the 5th. Square root of 25 is 5. So the factor is 2x times the quantity of 2x to the 5th plus 5 times the quantity of 2x to the 5th minus 5. Now it's your turn. Let's see if you learned something on this video. Do it yourself. Factor each completely. Number 1, 5x cubed minus 5x. Number 2, 81x squared minus 100. Number 3, 4a to the 8th minus 49b squared. Number 4, x to the 6th, y to the 4th minus 9z squared. Number 5, c squared minus 9 over 25. Don't forget to comment down below your answer. Happy learning! Thanks for watching. Please like and share. And don't forget to subscribe on my channel and click the bell button so that you will be notified whenever I'm going to upload a new one. Maraming salamat!